My name is Tom Kite, and I'm part of the engineering team at Audio Precision that developed the 555 hardware and the software that goes with it. I want to show you a little bit about the analog performance of this box. We spent a lot of time optimizing it and making it as good as it can possibly be, and we'd like to frankly show it off a little bit. What I've done here is I've set up a test. I've set up a situation here where I've got the system actually connected to itself. So we're not going to be testing a real device right here. I'm just going to show you the baseline performance of the system itself. So I'm going out the analog balanced and in analog balanced, and so I'm actually doing that with an internal loop back, so we don't need any cables. And so you can see over here I've got a sine wave at 2 volts, and so you can see it here in the time domain and here in the frequency domain. And just for the moment, I'm gonna pop this away so we can see a bit more of what we're looking at. And so yeah, there, as you said, there you can see a sine wave being generated and its frequency domain representation. Now, as you're probably used to seeing on audio analyzers, you can see here's the fundamental at a kilohertz, and here's the second, third harmonic, and several other higher order harmonics. And you know, obviously every real device has some distortion, and that's what we're seeing right here. And down here in the meter, you can see I'm looking at the total harmonic distortion and noise as a ratio to the fundamental, and you can see it's about minus 108 dB. So pretty good. Okay, so but at AP we're always trying to do better, and so one of the things that this box features is a generator that uses resistors and capacitors, actual analog components, rather than a digital to analog converter, which is how most generation is done these days. And so you can see over here I have a choice between either using the DAC generator, the converted sine generator, or using the actual pure analog sine generator. So let's switch to the pure analog sine generator. We call it the high performance sine generator. So I'll just flick over to it there, and you can see already that the distortion components have gone down substantially. And in fact, you can also see the THD has improved to about minus 115 dB. And this is a pretty good figure, but actually we're still interested in, well, could we actually do better than this, and can we reduce these distortion components further? And really, most of the distortion here is actually coming from the input side, the analysis side of the analyzer. It's really being generated inside the analog to digital converters that we're using to digitize the analog signal. So what we have in the box is a set of very special hardware that uses analog notch filters and some extra analog to digital converters and some digital signal processing to be able to essentially remove all of that distortion, or nearly all of it. So I'm going to engage it here. We call it the high performance sine analyzer. And now if we look at the FFT over here, you can see that essentially the distortion just isn't there anymore. And you can see that the total harmonic distortion and noise has gone down to better than minus 120 dB now, which is far better than any of the instruments that we've ever produced, and far better than anything that's in the market. So let's have a closer look at this FFT here. I mean, move it up a little bit, and as I said, you see pretty much a noise floor and the fundamental, and that's it. Let me engage a bit of averaging so we can get a better look. I'll put 10 averages on, and now you can just see the second harmonic poking out of the noise floor. But that's about it. There's maybe you can see a hint of a third harmonic there, but that's about it. And so using this technology, we're able to produce an instrument with extremely low inherent distortion. And of course, the advantage of that is that if you want to measure distortion on a real device, then you want the contribution to that distortion from the analyzer itself to be as small as it can possibly be. Otherwise, you end up measuring the analyzer and not the device. And so here we have an analyzer that generates vanishingly low amounts of distortion. So you can measure all of today's very best devices with this analyzer. So that's a quick introduction to the high performance analog that we have in the 555.
Find out more at Vicom's website.